An object with a weight of 50 newtons is attached to the free end of a light string wrapped around a reel of radius 0.250 meters and mass 3 kilograms. The reel is a solid disc, free to rotate in a vertical plane about the horizontal axis, passing through its center. The suspended object is released 6 meters above the floor. A. Determine the tension in the string and acceleration of the object, and the speed with which the object hits the floor. B. Verify your last answer by using the principle of conservation of energy to find the speed with which the object hits the floor. So this is chapter 10, problem number 45. We're going to first list the givens. We know that the force is 50 newtons, the radius is 0.25 meters, the mass is 3 kilograms, and that the height is 6 meters. We now list the finds. We need to find tension, acceleration, and final velocity. So the net force in the y direction is equal to mass times acceleration in the y direction. We have 50 minus t is equal to 50 over gravity times acceleration. We have tau is equal to I times acceleration. We have tension times radius is equal to I times acceleration, which is equal to I times acceleration over radius. We get that I is equal to 1/2 mass times radius squared, which is equal to 0.0938 kilograms meters squared. We get that 50 minus t tension is equal to 5.1 times tension radius squared over I, and you get that tension is equal to 11.4 newtons. So to find acceleration, we have acceleration is equal to 50 minus the tension, which is 11.4, over 5.1, and you get that the acceleration is equal to 7.57 meters per second squared. And to find velocity final, we have Vf squared is equal to V initial squared plus 2a delta x, and we get that V final is equal to the square root of 2 times 7.57 times the height, which is 6, and you get that velocity final is equal to 9.53 meters per second. Now, for part B, we have the equation k plus u initial is equal to k plus u final. We have that mass times gravity times height is equal to 1/2 mv squared plus 1/2 I double omega squared. We get that 2 times mgh is equal to mv squared plus I times v squared over r squared, which is equal to v squared m plus I over r squared. We get that velocity is equal to the square root of 2 mgh over m plus I over r squared. Plugging in our numbers, we get the square root of 2 times 50 newtons times 6 meters over 5.1 kilograms plus 0.0938 over 0.25 meters squared. You get an answer of 9.53 meters squared.